Hello and welcome back to another video. In this problem, we're asked to use the intermediate value theorem to show that there's a root of the given equation in the specified interval. We have sine of x is equal to x squared minus x on the interval from 1 to 2. So first we want to get everything on one side, and we do that by adding and subtracting these so that these cancel, and we're left with the sine of x minus x squared plus x equals 0. We're going to call this f of x. And we're going to say that f of x is equal to 0. We want a solution of this equation. So what we're going to do is we're looking at the interval from 1 to 2. So we take f of 1 is equal to sine of 1 minus 1 squared plus 1. And that is going to be roughly 0.84. And f of 2, plugging in 2 to the equation, we have sine of 2 minus 2 squared plus 2. Plugging that into your calculator, you get negative 1.09. We can say by the intermediate value theorem that since f of 1 is greater than 0 and f of 2 is less than 0, there exists some x value such that f of x equals 0, right? And we know that this x value is between 0 and 1. And therefore, in the interval from 0 to 1, there is a root of the equation. How do we know this? Well, what is the intermediate value theorem actually saying? If we have our function here, and we have x is equal to 1 and 2, f of 1 is positive, f of 2 is negative. We're saying there's no way to get from here to here without crossing the line, unless you're making some jump or skip or whatever, in which case the function wouldn't be continuous. We can say that it must hit all of these points. And we know that this function is continuous because we have a trig function subtracting a polynomial. Sine and the polynomial individually are continuous everywhere. We know that by theorem 7. And by theorem 4, we know that taking one and subtracting the other means it's going to have the same continuity, which means it's also continuous everywhere. And therefore, f of x is continuous everywhere, and therefore, by the intermediate value theorem, we can say that since we're starting greater than 0 and ending less than 0, there must be a point between this interval where we equal 0, and there's a root of the equation.